Okay, this is a video just basically going over, I wouldn't say necessarily a new harness design, but it's one that I don't typically do too often, and I sort of kind of learned my lesson. Moonshine on the forum a while ago purchased a harness, and some people, they insist on keeping simplicity, but they don't want to make a lot of connections and stuff like that. But then again, they also want to run a whole lot of current, so in this case, this customer has a 24 FET controller that he wants to use. This harness that I'm currently displaying is a 24S 4P with 5.5mm bullets, so he's going to use the zippy 8 amp hour packs and create a 88 volt 24 amp hour pack. So, it's the standard connections and everything. Due to the way that they were going to be situated on the bike, I kind of staggered the lengths a little bit to kind of match the pack lengths a little bit. One of the things that I typically have a problem with is whenever I use PP75s, these connections are very, very beefy. They can carry a lot of current, but the one thing is the retention force on them is so freaking retarded. Like each contact has a 50-pound retention force. So instead of them, making it like one of my one-plug harnesses with PP45s, that's easily to pull apart. This whole harness would have, about a 400-pound retention force, meaning if I made these into one big block and tried to pull it apart, it would take 400 pounds, if not more, force to pull it apart. So in order to keep it down to something manageable, I tried to do it in blocks of 4, where it will require 200 pounds of force to break the connection, but even still, for some people, that was too much. So the alternative is plugging them in one at a time. And the easiest way, and even still, that's 100 pounds of force. And some people still can't do that. So the easiest way to get these apart is if you rock the connection left to right a little bit as you're pulling on it. It'll wiggle it loose to where you can pull it out. So I'm not sure how I can display this, but I'm gonna try my best. Alright, there's a connection right here, and so what I'm gonna do is basically take the connection, wiggle it back and forth, and it comes loose. Alright, here's the second connection. Just flip it over so you can see that. Just wiggle it left and right, pull it out, and it comes loose quite easily. Same thing putting it in, just wiggle it back and forth, slide it in. Take this, wiggle it back and forth. You'll hear it click and it will slide in. Also, another thing that I'm doing is I think I've tried to let people know that it should be simple, straightforward, but still some people still get kind of bewildered on where the connections go. So in this case, I just printed in paint. I just made some long strips of color to where I can cut it out and I can tape it to the Anderson blocks to where, this pink goes to pink, that blue goes to blue, flipping the harness over, going to the other side, orange goes to orange, and green goes to green. So that should save a lot of the guesswork and plugging up certain harnesses. If anything, like if you have a harness with 4mm bullets, I may just tag the wire right here with some colored PVC tape so that this wire goes to this wire, that goes to that wire. Haven't done it in the past, but you know, it's still, I think there, with my harnesses, there comes a thing of common sense. You know, I do hope most of my customers do have the common sense that, you know, once you plug it together or see one of my videos, it should be pretty much straightforward for the rest of them, for the rest of the people, and I can recycle some of my videos to, you know, other customers that, hey, you have a similar harness, just kind of follow the same principles as what's going on in that video, to know how to assemble yours. Another thing that I've been getting a lot of requests for is putting the fuse in the middle of the pack, and so this is what I've done in this one. Actually, the way this bike, the user's bike is set up is he's going to have 8 packs on each side of the bike, and like so this area crosses over the tube, so this, you can always have like a quick visualization on what the fuse status looks like, it's supposed to be, and you know, like I said, the customers are requesting a fuse in the middle of the pack. Here's another instance where a customer, he has a 24S 2-piece set up and requested a fuse in the middle of the pack. And the way this works out, and I kind of frowned upon it before, but now it doesn't seem like such a bad idea, because one thing is the fuses I use are rated for like 12 to 32 volt use, so the closer that you stay to that rating, the better that it will act in, you know, in containing one, you know, when a DC fuse blows, it continues to arc, but once you start getting up to the higher voltage DC fuses, that cost a lot of money. These, trust me, these work. I've used them on my build. They do blow at the appropriate amperage and everything. It just depends on how violent the actual blow is. Since these are AGU fuses and there's a glass tube that's surrounding the fuse, so it keeps all of that, you know, all of the solder and the fragmented metal, it keeps it within the glass fuse cartridge. So all you have to do is, you know, pull it out, pop another one back in, and you're good to go. But again, these are supposed to be safe up to 32 volts. Some of us are running 88 volts and everything, so like when they blow, they can blow violently. And actually, when I tested my build out at 66 volts, 75 off the charger, it blew a 50 amp fuse because my controller was programmed to closer to 70 amps, so I blew the fuse. And when the fuse blowed, it actually cracked the glass fuse, so it was a very, very violent, you know, blow scenario. But I think if we can get the voltage lower, closer to the rating of the fuse, that it'll react a whole lot better. No matter how many amps you pull, it's going to blow at the appropriate amps, but depending on how violent that blow is, depends on the voltage. And by putting the fuse in the middle of the pack as these two scenarios, it should work a lot better. Another thing with my harnesses is, since I'm switching over to crimping, specifically this portion of the harness right here where the wires parallel, here's another section. This one is paralleling to and this one right here is paralleling 4. It's creating, when I crimp, it's creating what some foremen will call ears, and so it's almost, it almost looks like an arrowhead or a blade. And then you also have, there's a bale of the crimp sleeve that I use that you also have to deal with. So another good thing that I'm doing is this section right here. I'm double shrink wrapping just in case, the vibration, causes these to rub or something like that. They're double insulated with two strips of shrink wrap, so it should take care of any problem of any potential accidental shorting. I'm still looking at ways to try to counteract the so-called ears on it. You've seen the picture before of the crimp without the heat shrink on it. You'll see what I'm talking about. I think it's just one of those cosmetic things. I don't think there's going to be any true problem with it, but just for a safety precaution, I'm double shrink wrapping that. So that's just another update on what I'm doing.